Welcome to this explainer. If you've been following AI lately, you know we're right in the thick of a massive paradigm shift. We're officially moving from chatty LLMs to AI systems that actually get things done, completely autonomously. Today, we're unpacking exactly what that shift looks like, the hidden hurdles companies are tripping over, and how you can actually cross the chasm from early hype to rock-solid production. So what happens when an AI stops just talking and starts doing? We're moving way beyond basic chatbots here. Look, it's one thing to have an AI draft a quick email for you, right? But it's an entirely different beast to have an AI independently research a topic, draft that email, and then decide to send it to the right stakeholders without you ever lifting a finger. That jump from human-prompted action to autonomous execution is absolutely profound. But, as we're going to see, making that leap is proving to be incredibly difficult.
All right, let's jump right into part one, Beyond the LLM.
To really grasp why this is so tough, we have to define what an agent actually is. Unlike your standard LLM that just answers a single prompt and calls it a day, a true AI agent is like a tireless little digital worker. It actually plans sequences of actions, uses external tools to grab new information, remembers context across multiple steps, and independently decides when a task is perfectly complete. It's a fundamental shift from a simple text generator to a goal-oriented problem solver. And the secret sauce driving all this autonomy is something called the agent loop. It's basically a continuous repeating cycle. The system makes a plan, takes action by calling a tool, observes the result of that action, and then uses that observation to figure out its very next step. It stays in this loop, just churning away and dynamically adapting until the agent itself decides, yep, the original goal has been met, I'm done. And hey, this isn't science fiction. This multi-step execution is happening right now in real production workflows. We've got agents tackling super complex, high-stakes tasks, doing deep market research, drafting dense legal contracts, triaging messy support tickets, and even orchestrating cloud infrastructure. That last one is a massive deal for businesses. It means an agent is dynamically provisioning servers and resolving routing issues in real time with absolutely no human engineer having to click through a million steps. Which brings us to Section 2, the production scaling gap. Right now, a whopping 79% of companies are actively adopting or piloting AI agents. The hype is incredibly real. And on top of that, the data shows that 88% of enterprises are planning to increase their AI budgets significantly. Everyone is chasing that promise of unprecedented efficiency and lower costs. But here is the wild part. Incredibly, only about 2% of companies have managed to actually deploy these agents at real scale. Think about that drop-off. Despite all the adoption, the aggressive pilots, and the massive budgets, almost all of these initiatives hit a total brick wall before they ever see the light of production. So what's going wrong? Well, everyone is eagerly trying it out in tightly controlled sandboxes, running these little proofs of concept. But almost no one's systems are surviving real production loads and the endless unpredictable edge cases of the real world. In a live system, an agent hallucinating a command or getting stuck in an infinite loop isn't just a funny glitch, it's a severe operational risk that breaks everything. It's honestly such a huge challenge that Gartner bluntly predicts 40% of all AI agent projects are going to completely fail by 2027. Just let that sink in for a second. Nearly half of all these massive enterprise investments are expected to yield absolutely nothing. There is something fundamentally missing in how we're building and deploying these autonomous projects today. Let's talk about how to fix that. Section 3, Essential Agent Infrastructure. To avoid being part of that doomed 40%, we absolutely have to talk about the missing link here, and that is agent infrastructure. This is the hardcore engineering layer required to run an agent reliably. It's the difference between a fragile, cute demo that works exactly once and a hardened system your business can actually depend on every single day without holding its hand. At the very center of this infrastructure is the orchestration engine, and the thing that really makes this engine hum is tool calling. This is what brilliantly gives the underlying language model structured access to external functions mid-conversation. Whether it's running some Python code, doing a live web search, or pinging a proprietary database, tool calling is literally what gives the agent hands to touch the outside world within that plan, act, observe, and decide loop. But wait, a simple loop isn't nearly enough for enterprise scale. You also need memory, so the agent accurately keeps its context across long, complex sessions. You need multi-agent orchestration, which seamlessly coordinates teams of specialized bots, like a researcher agent passing notes to a writer agent.
And crucially, you need strict guardrails. These are the hard-coded safety constraints required to stop an autonomous agent from making a very expensive, irreversible mistake. Because getting this architecture right is literally make or break, spending on agent governance and security is skyrocketing. We're looking at spending hitting $492 million in 2026, and it's on track to cross the $1 billion mark by 2030. Companies are waking up to the fact that if they're unleashing autonomous systems, they need incredibly serious safety nets to monitor them.
The good news? You don't have to build all this heavy lifting from scratch anymore. Pre-built abstractions are stepping in to help. Awesome frameworks like LangGraph 1.0 are handling the complexities of the agent loop and memory. You've got the Claude Agent SDK mastering advanced tool calling, Crew AI streamlining multi-agent coordination, and Microsoft Agent Framework 1.0 tackling full enterprise deployment.
So, where does that leave us? Moving to Section 4, the human role shift.
With all this incredible automation, we are witnessing a profound shift for the humans involved. Traditional operations engineers are moving away from directly doing the work, writing code and submitting pull requests. Instead, the AI-era engineer is shifting to actively supervising the agents doing the work. Your job goes from typing out the commands yourself to setting the parameters and managing the agent's execution.
Think about how wild that is. This completely flips the definition of being on call. Your typical code review suddenly transforms into a fascinating audit of an autonomous system's reasoning process. You're looking at an action log to figure out why an agent chose a specific tool or how it handled an unexpected error, rather than debugging a human syntax error.
Finally, Section 5, avoiding deployment failure.
Okay, so how do we make sure our agents actually make it into that successful 2%? First, you got to compare frameworks directly by building the exact same task multiple ways. Second, you must study postmortems of the failures. Look for instructive disasters, things like infinite loops, tool misuse, or silent drift, which is when an agent subtly loses accuracy over time without ever throwing an error.
But honestly, the absolute biggest lifesaver here is implementing human-in-the-loop checkpoints. This is where an agent mathematically pauses its loop to ask for explicit human approval before doing anything high stakes or irreversible. It is the critical difference between a fun little toy demo and a system that is genuinely safe to leave running unattended in the real world.
So I'm going to leave you with this provocative question as we wrap up this explainer. Have you built a toy demo or a safe system that will survive contact with production? Understanding that difference is absolutely everything right now. Thank you so much for joining me to explore this massive shift, and I hope this helps you build smarter, safer, and infinitely more capable agents.